Hope everybody's still awake. My name is Nathan Day. I am one of the co-founders and currently the chief scientist of SoftLayer technology. And today I wanted to talk to you guys about performance. I've been working with businesses for the past decade of my life, helping them move workloads into a hosted environment. And one of the most exciting things in the last half of that decade has been the emergence of cloud. Cloud is really an awesome technology. It is another tool for our toolbox that gives us the power that we haven't had before. So we're thinking about things like consumptive billing, self-service provisioning. These things all help so that as IT professionals, we can do our jobs better. So there's a lot of options when it comes to the cloud. We just heard a great discussion on different types of clouds and what some of the latest thinking is when it comes to cloud. But today I want to talk about performance. And we'll try to figure out what characteristics of performance are out there, which ones should matter to you, and how you figure out how to judge those characteristics. So there's a popular theory out there that you can take any complex topic and simplify it using a car analogy. So if you'll indulge me, I think we'll go down that path. This is a BMW M5. That is the epitome of performance to a car enthusiast. You're looking at almost 600 horsepower. You can go 0 to 60 in under 4 seconds, and you can do it in style. Now that is truly performance. But is that performance for everybody? Look at the Toyota Prius, 51 miles per gallon. I guess that's performance too, isn't it? It's a different type of performance, but for some people that matters more. My wife, for example, would rather drive the Toyota Prius and get better gas mileage driving the kids around town than the BMW M5. I respectfully disagree. So you guys get the picture, but I'm going to hammer it home with one more point. It's a Tata Nano. In theory, it's going to be sold for $3,000. By almost any metric, as far as car per dollar goes, that's a lot of car per dollar. Now, it's small. It's not going to accelerate like the BMW. It's certainly not going to have the style the BMW has. It might have the gas mileage the Prius does, but it's going to be a little bit smaller. All right, so I've beaten home the point, killed the dead horse already. Performance means different things to different people. So let's see if we can bring this back around to the cloud. So here are some different elements of performance in the cloud. Processing, the billing model, the networking. Look at the feature list, uptime, management capabilities, and security. Which of those matter to you? Well, it depends, just like the car analogy goes. You're going to have different characteristics that are important to you and the workloads you're trying to run. Now, I'm not going to bore you by going into detail for all of these, but I've picked out a couple I'd like to dive a little deeper in with. We'll start with some of what everyone usually probably associates with performance when it comes to a server. CPU, memory, and disk. On the CPU side, depending upon your tolerance for performance, you might be very interested in exactly what CPU you have, what processor you have, how many cores you have, what's the layer 2, layer 3 cache inside that processor, how many memory channels come in that processor. To some people require a high degree of CPU performance, those things matter, and they matter a lot. When it comes to memory, you want to look at the bus speed of the motherboard. You want to look at the speed of the RAM itself. How much RAM do you need? When it comes to disk subsystems, then it gets even more complicated. You have to decide if you want RAID. Do you want SATA drives to have a large capacity, good value per dollar? Or do you want to have SSDs and get that extreme performance? And then how do you want to associate those drives together? Do you want put them together all in one big bunch of disk space? Or do you want to have RAID so you can have some tolerance for failure? Maybe you want to use RAID to increase the performance. So all these things matter, and what we're going to talk about today is you can't get all these things in a virtualized commodity cloud. When you're going to a virtualized commodity cloud provider, you don't have access to what motherboard. You don't get to pick the processor. You don't get to pick the exact disk configuration to your specifications. It just doesn't exist in the product list. Now, a quick word about virtualization. Virtualization's awesome. Think of all the things we can do today that we couldn't do 5 years ago without virtualization. We can split up workloads. We can take one big piece of metal and we can carve it up into many pieces. We can take some legacy applications that just have to run that we don't care about performance, and we can group those together with some other ones, and we can consolidate 20 servers down to one in some cases. But there's a cost to that virtualization. Anytime you put an abstraction layer in front of a system, you're going to take a performance hit. Now, that performance hit might be worth it for a particular use case, but if you're after pure performance, in a lot of cases, it's not quite worth it. This slide will elicit a couple groans from the audience probably, given that it's what are we, about 12 days away from tax day? There's a tax with using a hypervisor. And like I said, it's worth it in a lot of cases. But if you're truly after performance of the bare metal, you can't get there with a virtualized environment. So, how do you figure out which cloud environment is right for you? Do you want to go virtualized public cloud? Do you want to go bare metal public cloud? Do you want to go bare metal private cloud? Virtualized private cloud? A lot of options out there. The hypervisors matter. How big you want your servers or virtual servers to be, all that matters. And the only way to figure that out is to use some testing. Now, you can start with some public benchmarks out there. There's a lot of vendors even put out their own benchmarks. We put out benchmarks. Don't trust vendors' benchmarks. Go out there, find a third party, go run your own, or better yet, provision some environments as in either locally or in a hosted environment and test your app yourself. That's the only way you'll know if you're hitting the performance characteristic that's of interest to you. Hopefully your test harness isn't as complicated, or at least that messy. So just for example, we did a real simple benchmark. We took Unix Bench, just a simple, I guess it was started by Byte magazine back in the day. So if you're old enough, you remember that magazine. They've got a benchmark, and we just took a couple popular configurations at SoftLayer, and then some popular configurations at a commodity virtual public cloud, and we graphed those against the list price. This is the kind of exercise you guys need to be doing when you're looking for a cloud environment. That's the only way you're going to be able to judge whether that cloud environment is going to be effective for you. So a benchmark is good. The real app is better. So notwithstanding my comment about trusting vendor benchmarks, we set up a MongoDB environment. Actually, we set up several. I'm not going to talk about all the test cases we did. We have a blog on our website that goes into detail with our methodology and our results of several different tests, but I'll talk about one of them today. We took 4 single processor servers, ordered them from SoftLayer like a customer would, and then we went out to one of the commodity virtual public clouds and ordered a similar configuration. We took a data set of, it was 8 gig of half a meg documents, did a bunch of iterations. We had a 6-to-1 read-to-write ratio and a bunch of concurrent connections, and we made this a long-term test because we wanted to accurately judge performance over time, which will be important here in a minute. Here's a picture of our test setup. Pretty simple. Separate physical in the case of the SoftLayer environment, separate virtual servers in the case of the commodity public cloud environment. And we set up a separate server for a client, so we weren't running the client on top of the Mongo database machines. And then we had a data collection set up. So what we found isn't really surprising. We found that bare metal beats a virtualized environment. That's what you'd expect. You get direct access to the memory, you get direct access to the processor, you get direct access to the disk. So both reads and writes, we outperform the virtual public provider. So I mentioned we did a lot of tests. Here's a few of the tests we did with different sizes of deployments and different types of disk subsystems. And in every case, bare metal beat virtualized public cloud. Now this got to be interesting. We not only looked at performance, but since we repeated this test several times, we started looking at the standard deviation of the results. And this is important because performance is important, but so is consistency of that performance. When you're on a bare metal machine and you're in a single tenant environment, you control your own destiny. When you're in a public commodity virtual cloud, you don't control your own destiny. You don't know who your neighbors are. We actually feel bad for the people who are our neighbors when we were running this test out there in the cloud, because their performance surely went down during our testing. But look at the standard deviation. We're talking 4, 5, in some cases 10 times of the standard deviation. That jitter is going to make it very difficult for you to do proper planning when it comes to deciding how many virtual or physical servers you need, how much RAM. You have to, when you're doing your scalability planning, you're not going to have a deterministic value to go forward with. So that's something to consider as well. Let's move off processing and on to networking. The first type of networking I want to talk about is what's going on locally inside the data center. So if you're running a workload in the cloud, do you know where your workload is? Do you know what rack it's in? Do you know what switch it's on? If you're running a clustered workload out there, are your workloads in the same rack? Are they in the same row? Are they behind the same router? Are they in different rooms? This doesn't matter to everybody, but if you're worried about the milliseconds of latency between your servers, whether they're physical or virtual, it's very important to know where those workloads are at. You can get this from your own benchmarking. You have to provision an environment at the cloud provider or internally if you're doing a private cloud, but you still need to do that testing. For some cases, it doesn't matter. For some cases, it matters greatly. Let's look at another aspect of networking, and that's the internet at large. So this is something that's harder to test. It's really hard to tell what 1,000 people around the world are going to experience when they're on your website. There's a couple people out there that will help with that. A company called Sodexis actually helps people optimize their internet-facing workloads so they get better performance. They publish the response time as well as the error rate. Cloud Sleuth is another resource you can use. They look at the performance of the public cloud providers versus different points around the world. It's another good data point. Again, it's hard for you to test unless you want to go buy data centers all over the world. These guys are taking care of it for you. Let's talk about billing model real quick. And I mean really quick because I'm almost out of time. Billing matters when it comes to the granularity of your billing model. If you're paying hourly for a steady state workload, I bet you're paying too much. The simple analogy for this one is, if you pay for a hotel by the month, you're paying too much. You'd rather be in an apartment. Remember that when it comes to looking at your billing model. It's nice to have hourly, that's great, and it's wonderful for transient bursty workloads. We've got hourly, we've got monthly, other people have hourly, other people have monthly. You can go even longer term with some providers. So make sure to carefully consider that billing model with respect to the time it is. So it's not just the amount of it, but look to see if that model matches up with what you need. We've got some examples. I won't bore you guys with reading words, but we've gotten a lot of good user feedback in the last couple of years about people that have put their workloads on our bare metal. They've designed the subsystem of the disk, they've designed the memory and the CPU to fit their needs. So in summary, performance is in the eye of the beholder. You have to figure out what characteristics of performance matter to you. And you have to test them. You have to use benchmarks. Hopefully you can run your own application. It is extremely critical. You can't trust the vendor's stats. You can trust the third-party stats a little better, but please do your own. And last thing is virtualization is a tool. It's not a requirement for cloud. You can get cloud deployments of bare metal servers in a matter of hours. It's not the 5 minutes you get in a virtual public cloud, but you know, it's really the rare use case where I need that virtual server up in 5 minutes versus I can wait 2 hours and design my own physical infrastructure so I get what I want. So if there's one point I'd like to leave you with, and I think I've hit it pretty hard today, you have to do your own testing. Figure out the characteristic that matters the most to you and optimize on it in a cloud environment. And it doesn't matter if it's a public virtual cloud, public bare metal cloud, or a private cloud. Thank you.
Thanks a lot, Nathan.